All right, so in the first part of the video, we calculated the Riemann sum of a curve, and so everything that we've been finding the areas of so far has been kind of weird, kind of squirrely looking curves, you know, something like this, and then we break it up into different rectangles like that. But, you know, sometimes we'll have it to where it's just going to be a straight line, and we can just, you know, figure out the area normally. So, we're going to look at this example right here. So we want to calculate the area of two similar yet different equations, curves. We want to do the integral, so finding the area underneath the curve from 0 to 5, so 0 to 5. Of 3 minus x, so that's this first one right here, and then the absolute value of 3 minus x, which is going to be this one right here. All right, so we're going to look at our first one. All right, so remember in the last video I told you that if the area is above the x-axis, then it's positive, so everything in here is positive. And then if it's below the x-axis, then it's negative. So basically what I got to do is I'm going to take the area of this right here and then going to subtract the area of this right here. And so if you look at it and you kind of draw in your axis, you see that you've got, in your boundaries, you've got two different triangles. So basically what I'm going to do is I'm going to calculate the area of my two triangles. So this bottom one right here has a base of 3 and a height of 3. So area of a triangle is 1/2 base times height. So this area right there is going to be 4.5. And then this triangle right here has a base of 2 and a height of 2. So 1/2 base times height gives me 2. But then since this one is below my axis, it's got a negative area. So then it's negative. So 4.5 plus negative 2 gives us 2.5. That is what the total area is. So now going and looking at my absolute value function. So remember, absolute value, basically whenever you have a negative value, it takes it and makes it positive. So from a kind of graphing standpoint, it's the same graph as normal, but then when it gets right here, it flips everything over. So what that means is I've got two positive triangles. So I'm going to find the area of both of those and I'm going to add them together. This is the same triangle as right there, so that has an area of 4.5. And this is basically the same triangle right here and as in the first one, except it's flipped over. So that has an area of 2. But since it's above the x-axis, it's positive, so we add them together. So 4.5 plus 2 gives us 6.5. So these are our two areas. So if they give you one like this, if you just, you know, draw out the graph and then just calculate the area geometrically, and it's and when you graph it on graph paper, you know, it's, if you graph it correctly, you should be able to kind of figure out what the shapes and the links are and calculate the area. All right. So next we have a bunch of rules that you need to know. So these are also in the notes that were posted on Edmodo. If you're writing it down, pause it, copy it all down, and then unpause it, and we'll talk about it. So, whenever you integrate a constant, so that's the first one. First, we'll remember the integral of a constant is you just do the constant times x. So if you're doing an integral of a constant from a to b, you just do that constant times the difference of the two. So like the integral of 1 to 4 of 3, that would just be equal to 3 times 4 minus 1, which would give you 9. So other rules, if you're adding two integrals together, So if you're doing an integral of two functions added together, you can split it up. Take the integral of the first function plus the integral of the second function. And these are kind of similar to some of the other rules that we've seen before. If you've got a constant in front, you can pull it out. This one is very interesting. So we're saying a is smaller than b. So if we're doing the integral from b to a, so that would be a backwards integral, it's going to be the negative integral from a to b. So like the integral from 4 to 1 of f of x, doesn't matter what f of x is, that's going to be equal to the negative integral of 1 to 4 of f of x. And then this one right here, additivity for adjacent intervals. Basically, if your interval can be split up into two smaller subintervals, they're going to be equal to each other. So like the integral from 1 to 3 of f of x is going to be equal to the integral of 1 to 2 plus the integral from 2 to 3. And then also setting it up like if this was kind of an algebraic equation, the integral from 1 to 2, and I'm kind of doing some shorthand here, is going to be equal to the integral of 1 to 3 minus the integral from 2 to 3. And we'll do an example of that here in a minute. So our first example, we want to calculate the integral from 0 to 3 of 2x squared minus 5 dx using the formula. The integral from 0 to b of x squared is b to the third over 3. So what we want to do is we're going to take this integral and we're going to split it up. All right, so integral from 0 to 3, 2x squared minus 5. Well, we know that we can rewrite this as the integral of 0 to 3 of 2x squared minus the integral, oh, no, so we got to put the dx's there, minus the integral of 5 dx, and that's from 0 to 3. So the integral for 5, using our rule, we know that that is going to be equal to 5 times 3 minus 0. 3 minus 0 is 3. 3 times 5 is 15. So this right here is equal to 15. Just this part right here. So then we have the integral of 2x squared. Well, we can put the 2 in front. So this integral is going to be equal to 2 times the integral from 0 to 3 of x squared dx. So hey, the integral from 0 to something of x squared is equal to that. So 2 times, so our b in this case is 3, so 3 to the third over 3, minus this part right here, which we said was 15. So 3 to the third is 27, divided by 3 is 9. 2 times 9 is 18, so 18 minus 15 gives us 3. So that is what our integral is using all of our rules. Next section, I'll teach you a much easier way of doing that, but now you kind of get how you can kind of combine and split up your integrals when you need to. So then another example. So in this case, we're going to do the integral from 4 to 7 of x squared dx, and we're going to use the same property that we used last time. So the integral from 0 to b of x squared dx is equal to b to the third over 3. All right, but so our bottom number needs to be 0, but this is not 0, that is 4. So we do know that the integral from 4 to 7 is going to be equal to the integral of 0 to 7 minus the integral from 0 to 4. So while we can't figure out what this integral is, we can figure out what these two integrals are. So the integral from 0 to 7 is going to be 7 to the third over 3. The integral from 0 to 4 is going to be equal to 4 to the third over 3. So then using my calculator, 343 over 3 minus 64 over 3 is going to give us 279 over 3, which simplifies out to just be 93. So you know how you can split some of your integrals up. Make sure you have some graphing paper because you might need to graph some of these. That'll make your life a little bit easier. And it also might be helpful to kind of see it graphically. So we got some more stuff to do tomorrow in class, so I look forward to seeing all of you. If you're watching this in class in the library, very disappointed in you. And we will start having chats whenever you don't watch the videos at home. So stop not doing what you're supposed to be doing.